Washington. Magnetars are among the universe's most extreme objects, a class of the compact stellar remnants called neutron stars that possess immensely strong magnetic fields. Once in a while, they produce enormous eruptions of gamma rays in the strongest non-destructive release of energy known in the cosmos. Scientists have now detected the most distant known instance of one of these eruptions, called a giant flare, from a magnetar residing in a galaxy called Messier 82, or M82. This surge of gamma rays, the most energetic form of light, unleashed in just a tenth of a second the amount of energy our sun would emit in a span of roughly 10,000 years, they said. Only 2 confirmed giant flares have been observed in our Milky Way galaxy in 2004 and 1998, and only 1 previous one in another galaxy, in 1979 in the Milky Way's neighboring Large Magellanic Cloud, the researchers said. Giant flares are very rare events, said astrophysicist Sandro Marighetti of Italy's National Institute for Astrophysics, INIF, in Milan, lead author of the research published on Wednesday in the journal Nature. The Milky Way contains at least 30 magnetars, possibly many more, which have not been seen to emit giant flares. M82, nicknamed the Cigar Galaxy, because when viewed edge-on it has an elongated and cigar-like shape, is 12 million light-years from Earth in the constellation Ursa Major. A light-year is the distance light travels in a year, 5.9 trillion miles, 9.5 trillion kilometers. The magnetar giant flare from the Large Magellanic Cloud was about 160,000 light-years from Earth. The M82 giant flare was the most distant known but not the most energetic. The one spotted in 2004 had the energy equivalent to about 1 million years of output from the Sun. While there are more energetic cosmic events such as supernova explosions at the end of a massive star's life and gamma-ray bursts caused by 2 neutron stars merging, those involve destruction, unlike giant flares. Magnetars also emit occasional surges of gamma rays and X-rays at lower energy levels than giant flares. Neutron stars are born in the explosion and collapse of stars 8 to 25 times the mass of the Sun at the end of their life cycle. They compress 1 or 2 times the Sun's mass into a sphere only the size of a city. They are the most compact and dense astrophysical objects. They are as dense as atomic nuclei, INAF astrophysicist and study co-author Michela Rigoselli said of neutron stars. The main trait that sets magnetars apart from other neutron stars is a magnetic field 1,000 to 10,000 times stronger than an ordinary neutron star's magnetism and 1 trillion times that of the Sun. We can say that magnetars are neutron stars powered by their own magnetic energy. This does not happen in ordinary neutron stars, Mr. Marighetti said. A giant flare originates from a reconfiguration and a reconnection of the magnetic field of the magnetar, Ms. Rigoselli added. The magnetar in this research is believed to spin rapidly, perhaps completing a rotation every few seconds. Its giant flare was detected by the European Space Agency's Integral Space Observatory on November 15, 2023, in M82, a galaxy boasting a star formation rate much higher than the Milky Way's, called a starburst galaxy. The fact that Messier 82 is so active in star formation is relevant for our finding, Ms. Rigoselli said. In such an active galaxy, there are many young, massive stars like those which evolve into supernova explosions and give birth to neutron stars. It would have been suspicious to detect a magnetar giant flare coming from a quiescent galaxy. Well, folks, this news really gives us a glimpse into the wonders of the universe. Magnetars, like the ones mentioned here, are truly fascinating objects that showcase the incredible power of cosmic phenomena. The detection of such a distant gamma ray burst from a magnetar in Messier 82 is quite a remarkable feat. What's particularly interesting is how these giant flares compare to other cosmic events like supernova explosions. It's also fascinating to learn about the unique properties of magnetars, such as their incredibly strong magnetic fields, which set them apart from ordinary neutron stars. Overall, this discovery underscores the importance of continued exploration and research in understanding the complexities of our universe. It's truly remarkable what we can uncover when we delve into the depths of space.